Today I am going to discuss one problem based on the combustion reaction. So here problem statement is a natural gas consisting of 75% methane and 25% nitrogen is burnt in a furnace. The carbon dioxide is carved out of the resulting products for use elsewhere. The exit gases from the scrubber analyzed at 6% oxygen and 94% nitrogen. Calculate the percentage of excess air. So that we have to calculate. Now here is the diagram. In the diagram, methane is the natural gas is entering the furnace. In natural gas, methane is 75% and nitrogen is 25% entered the furnace, and that air is also entered the furnace because natural gas will burn with oxygen, so that oxygen will actually coming from air, and then that will produce flue gas. In that flue gas composition is carbon dioxide, oxygen and nitrogen, and then that flue gas will enter the scrubber where that carbon dioxide will scrubbing out, and then scrubber gas remaining gas composition will living as a scrubber gas like here in the scrubber gas oxygen is 6% and nitrogen 94%. Now hints is given: consider hundreds mole of exit gas and assume x mole of natural gas and y mole of air entered the furnace. Set up the linear equation by overall material balance for nitrogen and oxygen and solve in excel. Okay, so here I'll solve by hand. Okay, not excel, so we can do that, no issue. Now here okay, so now I'm solving the problem answer. Now I'm just copying the flow sheet. In that flow sheet, so natural gas is coming to the furnace. Now here hints 100 moles of exit gas, so that scrubber gas is 100 moles. So in that 100 moles, oxygen is how much? 0.606 into 100. So that is 6 mole. Nitrogen is 94%. So 0.94 into 100. So that is 94 mole. And X mole of natural gas. So natural gas amount is X mole. In that X mole, CH4 is 75%, means 0.75 into X, and nitrogen is 0.25 into X. So X mole is natural gas. So methane will be 75%, means X into 0.75, that is 0.75 X mole, and nitrogen will be moles, 0.25 into X, that is 0.25 X moles. Now air is air, y mole of air enters the furnace. So that air will be y mole. So y moles of air. Okay, and we know air contains 79% nitrogen and 21% oxygen. Now y moles air is entering the furnace. So now in that y moles air, nitrogen will be nitrogen in y moles air equal to 0.79 into y, and oxygen in y moles air will be 0.25. So now we have all these things. Now here in the furnace reaction is going on, so that methane, can change the color, methane plus oxygen 2 oxygen, so that will produce carbon dioxide and water. Now here we can say that 1 mole methane reacts with 2 moles of oxygen. Now in the natural gas we have 0.7 x moles of methane, so 0.75 x mole methane reacts with 2 into 0.75 x moles of oxygen, so means 1.5 x moles of oxygen. Means to burn 0.75 x moles of methane, oxygen required 1.5 x moles. Okay, that is required. Now from here, so supply air in supply air oxygen amount, that is 0.21 y mole. Okay, so supply air, this is, and this is. Now if we do the oxygen balance, now we can do oxygen balance. How to balance? Supply oxygen minus required oxygen or consume oxygen is equal to excess oxygen, that is exit oxygen. Now supply oxygen is here 0.21 y mole, 0.21 y mole minus required oxygen for combustion, so that is 1.5, that is here 1.5 x mole, 1.5 x mole. And what is the excess oxygen? So that is exit, so that is here, so that is 6 mole, 6. So that is equation number 1. Now nitrogen balance. Nitrogen in natural gas plus nitrogen in air that is equal to living nitrogen as a CRUBVD scarved gas. Now nitrogen in natural gas, so that is 0.25x, nitrogen in air, so that is 0.79, and that scrubbing gas is 94 mole. Now we can write 0.25 x plus 0.79 y, that is nitrogen air, is equal to leaving nitrogen as a scarf gas, so that is 94. So that is equation number 2, or equation number 1 and equation number 2. Now we can write nicely. So equation 1 is 0.21 y. Okay, so I'm writing minus 1.5 x plus this equation is equal to 6, and 0.25 x plus 0.79 y is equal to 94. Now we can write as a matrix form. Now we can write as matrix form. So that is minus 1.5, 0.21, 0.25, 0.79 x and y is equal to coefficient matrix will be 6 and 94. Now that is A, that is X, that is B. Now we can write as AX is equal to B form. Now X will be A inverse of B. So now we can write minus 1.5, 0.21, 0.25, 0.79 inverse into B, 6 into 94. Now if we solve in Excel, we'll get X will be like that. Matrix will be 12.12 and another will be 115.15. Okay, for Excel we can use Excel. First write A matrix and B matrix, use M inverse to calculate A minus, and then M mult, so that is A inverse into B. Now we got X is equal to 12.12 moles, Y is equal to 115.15 moles, means amount of natural gas is equal to 12.12 moles. Amount of supplied air one 115.15 moles. Now in supplied air, how much oxygen is there? Okay, that is supplied air is this. Now we can calculate oxygen required for combustion. So that is, you can see here, oxygen required for combustion. So that is oxygen 1.5x mole. So that is 1.5x mole. So that is 1.5 into 12.12 moles. So that will be, we can calculate. So that is, we can calculate with 1.5. So that will be 24.1815. 24.1815 moles. We can do the calculation. Uh, 1.5 into 12.12. That is okay. So that is not 24. That will be 18.18 mole. So that is oxygen required for combustion. Now we can calculate. So theoretical amount air required, you can calculate. So that is, 18.18 by 0.21 moles. How? So we know 21 mole oxygen present in 100 moles of air, and 18.18 mole oxygen present in 100 by 21 into 18.18. So that is into 100 divided by 21. So that is moles. That is 86.57 mole. Okay. Now here we can write supplied air is supplied air is 115.15 mole, 15 moles. Air required for combustion, that is 86.57 moles. So now excess air is equal to 115.15 minus 86.57 moles. So that is minus 115.15 moles. That is 28.57 moles. Now percentage of excess here, so that is 28.57 by theoretical amount 86.57. So that will be into 100. So that will be how much? 28.57 28.57 divided by 86.57, that is 33%. 33% excess air. Now here so excess air is in excess air oxygen is 28.57 into 0.21%, so that mole, so that is 28.57 into 0.21, so that is 5.9997 moles, means that is 6 mole. So that is in exit oxygen amount, means our calculation is correct. So now excess here, that is 30%. So that is our problem. Okay, now again I am repeating. So here first we have to calculate how in x mole, so we first assume x mole natural gas and y mole air. So here how much methane and nitrogen is there, how much nitrogen oxygen is there in the air, then we make the balance. From that balance how much oxygen is required. Okay, and then we have to do the oxygen balance and nitrogen balance. Oxygen balance, supply oxygen and required oxygen, or consume oxygen for the combustion, and excess air. So this is one equation. And nitrogen balance, nitrogen in natural gas plus nitrogen in air, and leaving nitrogen as a scrubbed gas. So that is 0.25 plus x, so plus 0.791 is equal to 94. Now we have, if you reorganize the equation 1, so we'll get minus 1.5x and 0.21y is equal to 6. 0.25x plus 0.791 is equal to 94. Now we can write as a matrix form, so that is minus 1.5, 0.21. So now if I solve in Excel, we can use M inverse and M mult. Okay, and we can solve 12.12 and 1515. So that is x. So now x means x small x is equal to 12.12 moles, means 12.12 moles of natural gas, and y is equal to 115.15 moles. So that means amount of supply air. Now here we have to calculate how much oxygen is required for combustion. So that is 18.8, and that oxygen is coming from air. So how much air is required? So that is 86.57. Okay, we know 21 mole oxygen present in 100 moles of air, so 18.18 moles of oxygen present in 86.57 moles of air. Now this is that requirement for combustion. Now what will be the excess? So supply air is this, and air required for combustion is this. okay, and excess air is 28.57. So percentage of excess air, so 20, that is excess by theoretical, okay, means whatever means amount of oxygen required, air required for combustion, so that is 86.57. so a 28.57 by 28.57 by 26.57 into 100, okay, so then we'll get 33% of excess air. Now if we do the some back calculation whether our result is correct or not, so in excess air oxygen is 20, so we know 28.5% excess air, and we know that in the air 21% oxygen is there, so if we multiply the 21, so we'll get the amount of oxygen, so that is 5.997, that is nothing but 6 mole, so that is in that exit amount, so it means our calculation is correct. Thank you for this problem.